Out there in the profound obscurity of room, the James Webb Space Telescope investigates the obscure for replies to the universe. The most recent Eye in the Sky by NASA captures stunning images of planets, galaxies, and stars. Unexpectedly, something significant has been discovered, and it has the potential to shake everything we know. Scientists are scratching their heads and pondering the possibility of the end of the universe. Go along with us as we investigate how another disclosure by the James Webb Telescope might actually annihilate the universe. At the point when we investigate the closures of the world, our beginning stage is the noticeable world. It's like looking out a window at the great places that lie beyond. The universe contains all that we can see, measure, and notice utilizing our telescopes and space tests. There is an assortment of stars, systems, and heavenly bodies accessible for our review. Yet the noticeable world is just a small part of the entire universe. Consider it a little piece of the immense universe that we can study and comprehend. Be that as it may, the size and state of the whole universe is a secret. Researchers gauge that the breadth of our noticeable air pocket is 93 billion light-years. The distance that light travels in a year is called a light-year, and it is approximately 588 trillion miles, 946 trillion kilometers. Thus, when we discuss the distance across of the noticeable universe being 93 billion light-years, we are examining a region that's still up in the air. Around 13.8 a long time back, the universe showed up in an extremely strong blast known as the enormous detonation. This blast began what is known as the extension of the universe. Since that incredible birth, the universe has not been totally open. Its extension has been fast. Strange powers like dull energy appear to be driving this speed increase, pushing the limits of the universe all over. Under the influence of gravity, matter began to coalesce as the universe expanded. Particles were brought together by this energy force, resulting in amazing structures like stars, galaxies, and planets like our own. Consider the times when these world designs developed into the different and now and again unnerving peculiarities that portray the universe today. The universe is extremely empty, despite its enormous size. The nearest star would be 2 football fields away if we reduced our entire solar system to a quarter of its current size. The smooth way world stretches out into our own system, showing how tremendous the universe is. You may be wondering why we cannot simply observe the entire universe. There are many purposes for this constraint. To start with, light, the quickest thing in the universe, consumes a large chunk of the day to go through space. This implies that when we take a gander at far-off objects, we are investigating the past. The more extended the article, the more it takes for the light to contact us. It resembles glancing through a time machine and disentangling the historical backdrop of our universe while noticing systems a large number of light-years away. The entire universe is expanding. Consider the traces left by an inflated balloon on its surface. The dots become further apart as the balloon expands. The universe operates in the same way. As space expands, galaxies disperse like those dots. This development makes light coming from far-off objects change shape, known as redshift. Basically, when items move away, the frequencies of light are extended, moving to longer frequencies which seem red. Given the movement season of light and the size of the universe, it isn't as business as usual that we have not yet seen the whole universe completely. We only have a limited understanding of these fundamental aspects of the universe, even with the most advanced technology and telescopes we have. Many academics have been captivated by the quest to comprehend the universe's edges and potential boundaries. 3 popular theories have emerged, each of which provides an intriguing perspective on the universe, despite the fact that there are still no definitive answers. 1. The limitless universe theory *. This hypothesis proposes that the universe is boundless and has no clear end. In light of the guideline of isotropy, which states the consistency of the universe according to all perspectives, this hypothesis recommends that the universe has no limits and stretches perpetually every which way. 2. The limited yet endless theory *. This hypothesis suggests that albeit the universe is limited, it doesn't have an unmistakable surface. All things being equal, it resembles an extraordinary hurricane, bended like a circle. In this scenario, similar to traveling around the Earth, if a person moves in one direction, they will eventually come back to where they started. 3. The multiverse theory. According to this theory, our universe is just one of many. Envision a large number of equal universes, each with a novel arrangement of actual regulations, real factors, and qualities. These universes can be totally different or associated through complex cycles, making a multi-layered and many-sided multiverse. The James Webb Space Telescope, JWST, is a reference point revealing insight into the secrets of the universe's beginnings. We can now see much further into the past than we could have imagined thanks to this amazing tool's singular capacity to unearth the mysteries of our universe's past. The JWST spacecraft is a technological marvel made to precisely observe the universe. Its high-level capacities stretch out our view to the earliest seasons of grandiose history. As of late, a review distributed in the diary Nature uncovered the disclosure of 6 huge JWST systems situated somewhere in the range of 500 and 700 million years after the enormous detonation. Curiously, these old systems surprise everyone, flaunting sizes bigger than anticipated for their initial life. These astounding discoveries challenge traditional comprehension of the arrangement and advancement of worlds in the early universe. The age of these galaxies is the most surprising aspect of these observations. In opposition to prevalent thinking, these divine monsters show a degree of development similar to our 13-billion-year-old smooth way. The size of the stars in these Goliath worlds is impossible, and they are billions of times the size of our Sun. Incredibly, one of these systems can hold a heavenly mass 100 billion times that of our own Sun, predominating the mass of our smooth way. JWST's remarkable capacity to comprehend the universe's secret districts depends on the utilization of infrared light, a range undetectable to the natural eye. This astounding power permits the telescope to catch the weak beams of old stars and cosmic systems, uncovering the remaining parts of a universe that has gone on for billions of years. Basically, JWST goes about as a time machine, taking as much time as is needed and giving incredible understanding into the universe as it unfurled 13.5 quite a while back. Our understanding of the history of the universe has been altered by the recent discovery of massive galaxies known as universe breakers. Like revamping history with an astonishing turn difficulties the vast majority of the models we've worked for early cosmic systems. At first, it was thought that stars and dust formed galaxies that grew in size and complexity over time.